In this question, we are asked how many significant figures are in the number 402,000. So first off, let's talk about the rules for finding significant figures, specifically for big numbers with no decimal point. Now the reason I'm talking about significant figures first is because chemists are very, very big on significant figures. Any calculations you do depend on how many significant figures are in the number you started with. Now we'll do more on that later. So for those of you who haven't seen anything about significant figures, here are the rules for big numbers without decimal points. The trailing zeros are not significant. And when I say trailing zeros, I'm referring to those zeros on the end. But sandwiched zeros that are in between two other numbers are significant. So that zero there in the middle between 4 and 2 is significant. But these other zeros on the tail of the number are not significant. So if we write the number down 402000, the numbers I'm boxing in red are the trailing zeros. And they are not significant. They don't count toward your significant figures. However, all of the numbers that come before it, including the zero in the middle, are going to be significant. Therefore, based on that, the numbers in green are significant, and the numbers I've boxed in red are not significant. So how many significant figures would be in this number? You have 3 significant figures. Now, these significant figures will influence our scientific notation as well. Because there are 3 significant figures in the original number, there will also be 3 significant figures when we change to scientific notation. So on this new slide, let's write down our number. I'm going to paint the significant numbers green. Now, when you have a big number, the decimal point starts here, right there on the edge. Now, for scientific notation, we want it to be between the first 2 numbers. And it's always going to be between the first 2 numbers. We're going to place it in between there. And what we need to do is to count how many moves that it's going to take to move the white dot over to the yellow dot. Okay, so let's count this out. It will take 1, 2, 3, 4, 5 moves. 1, 2, 3, 4, 5. So what we can say is in scientific notation, you can write only the significant figures. So we're just going to write the ones I wrote in green, and we're going to say 4.02, and in scientific notation, we also put on times 10 raised to the number of moves you had to make. So we counted, since we have 5 moves, we put a 5 up there in front of the 10. So 4.02 times 10 raised to the 5th power. So if we do that in the Google calculator, let me go ahead and open up Google, and you say 4.02 times 10 raised to the 5th, it will give us the original number back, 402,000. That's exactly what we started with, so we verified that this scientific notation matches what we started with. So now let's go over the rules for using scientific notation with small decimals. So if you have a small decimal, we can follow the same general procedure. Let's write the number down, and we want the decimal point to be between the first two non-zero numbers. So we're going to place our yellow marker in between the 1 and the 2. That's the first two non-zero numbers. And then count how many moves it would take to get the white over to the yellow. Okay, so let's have a look here. Here's where the white marker is. That's where the decimal point started. To get it over to the yellow marker, we would have to make 1, 2 moves. So when we write our scientific notation, we first have to figure out how many significant figures to write here. Now for the significant figures, for sigfigs in a small decimal, the rules are slightly different from if we had had a big number. In a small decimal, we are going to ignore the leading zeros. On the left, you'll see this little string of zeros right here before we actually get to the number. Those two are what we call leading zeros, because the leading zeros are not significant. Any other zeros, or any numbers at all, are significant. So therefore, the 2 zeros I've boxed in won't count, but the 1, the 2, and the 5 will all be significant. So, our number has how many significant figures here? Well, we would say there are 5 total numbers, but the leading zeros, which are 2, are not significant, and therefore we'll have 3 significant figures. Therefore, our scientific notation should have 3 significant figures. So let's write down 1.25 times 10 raised to something. Now, big numbers, like the one we did previously, get positive exponents. However, small decimals get negative exponents. So we can say, since it took 2 moves to get the decimal point in between the first 2 numbers where we want it for scientific notation, we can put a 2 up here. But because we started with a small decimal, this is going to be a negative exponent. And therefore, we can say the answer is 1.25 times 10 to the negative 2. So that's important. Remember, your small decimals get negative exponents, and big numbers get positive exponents.